stage-discharge relationship is represented using rating curve. The stage and corresponding discharge we use to plot this curve are measured during the data collection period. With this relationship, we can achieve continuous monitoring of stream flow via routine operation. Where the correlation remains unchanged with time, which is the case for majority of streams and rivers, we can say the relationship is under permanent control. A control refers to the combined effect of channel and flow characteristics. When we have a permanent control, we can use the same rating equation to describe the stage-discharge relationship. In this equation, CR and beta are rating curve constants that need to be determined via the best fit line. A is a constant that represents the stage for zero discharge. It is impossible to measure this hypothetical parameter in real life. We can only estimate the value of A using several approaches. First, we have to plot stage against discharge to an arithmetic scale. Next, we draw a best fit curve for the data points. Then, 3 points, namely A, B, and C, need to be selected. The value of discharge associated with these points should be in a geometric progression. For instance, the ratio of discharge at A to B equals to the ratio of discharge at B to C. From here, we have two options to proceed. The first option is by using Running's method. Vertical lines are projected from point A and B, while horizontal lines are drawn from point B and C. Next, we identify the intersection points D and E. After joining points A, B, and D, E with two straight lines, we are expected to see an intersection point F. Value of stage associated with point F would be the value of A. If we are taking the second option, we would need to note the value of stage associated with point A, B, and C. Next, we can simply apply this formula and calculate A. Once we obtain the value of A, we can proceed with the development of rating curve. Although we can always plot the data points in arithmetic plot, it would be easier for us to determine the rating equation when we do it in logarithmic plot instead. Constants CR and beta are defined using least square error method. By taking logarithm of the rating equation, we obtain a linear equation. Variables y and x of the linear equation are log q and log g minus a respectively. The gradient of the best fit line is beta, while the y-intercept is log cr. Given n numbers of data points, we can calculate both beta and y-intercept by implementing regression technique. The correlation coefficient R denotes how y and x are correlated with each other. Positive R value means both variables are positively correlated, and this should be our case. Value of 1 means both parameters are in a perfect correlation. Value greater than 0.6 shows good correlation. The following example shows the data of stage and discharge obtained from field measurement. At first, we need to find A. Let's plot the stage versus discharge and try to produce our best fit curve. For illustration purpose, we will use both approaches and see whether the results differ much from each other. Let the values of QA, QB, and QC be 500, 1000, and 2000 qmet. These values are in a geometric progression as the ratio of discharge for adjacent points is the same. By applying Running's method, we form a grid above point A and B, and from here, we mark our point D and E. By joining A, B, and D, E with two straight lines, we get our point F. This point corresponds with a stage of 7.6 meters. As for the second approach, we would need the stage value for point A, B, and C. They are 8.7 meter, 9.4 meter, and 10.7 meter respectively. By substituting these values into the equation, the computed A equals to 7.88 meters. The values of A obtained from both approaches are quite consistent. Let's take it as 7.88 meters and we are good to proceed. For our convenience, we will work directly on the data table. Knowing the value of A, we can append one column to the table and calculate G minus A. Then, let's take its logarithm and label it as X. At the same time, the logarithm of Q is calculated and labeled as Y. We will neglect data that produce negative G minus A value, as it is impossible to obtain its logarithm. In this case, the number of data available left only 12. Afterwards, we will append 3 more columns, namely xy, x squared, and y squared. Finally, we calculate the columnar sum for x, y, xy, x squared, and y squared. The subsequent step is straightforward. By substituting the values into the equations, we can find the values of beta and log CR. As for CR, all we need to do is simply anti-log it. Lastly, let's calculate the correlation coefficient. The value of R is very close to unity, and thus the correlation is considered very good. Thank you for watching. If you find this video helpful, please share it with your friends. We'll see you guys soon. Goodbye.